Hello learner, I am Dr. Poornima Tiwari, Assistant Professor of Mathematics, the Bhopal School of Social Sciences. In previous video, I explained about triple integrals with constant limits, that is a function with three variables x, y, z is given in the region R, where x is bounded by p and q, y is bounded by r and s, z is bounded by t and u. All values of the limits p, q, r, s, t, u are constants. In this video, you are going to learn about solution of triple integrals with variable limits. That is, when one or more value from p, q, r, s, t and u are function of x, y or z. First, we will solve this integral for the limit 0 to 1 x square to x, 0 to xy with respect to x, y and z. Here you may see the limits are function of x and x or y. So, whenever we have variable limits, we must perform integral as per given order. So, first we will write this integral as integral 0 to 1 integral x square to x. First we will solve for this limit 0 to xy with respect to z. So, the integral 0 to xy with respect to z and this dx dy as it is. Now, we integrate with respect to z, we get only z and the limits are 0 to xy. Now, when we apply the limits, here we will get upper limit, that is xy minus 0. So, on solving we will get integral 0 to 1 integral x square to x, xy dx dy. Now, in the second integral, we will solve for the limits x square to x to this function xy with respect to y. So, we get 0 to 1 integration for the limits x square to x of the function xy with respect to y and then with respect to x. Now, when we integrate this function with respect to y, x will deal like a constant and will integrate only y. So, we will get 0 to 1 x as it is, integration of y is y square by 2, limits are x square to x and then dx. When we write limits x as it is, we will substitute x in place of this y square. So, we will get x square by 2 minus lower limit, we will substitute x square in place of y square. So, we will get x to the power 4 by 2, this dx as it is. Now, we will multiply this x. So, we will get integral 0 to 1 x cube by 2 minus x to the power 5 by 2. Now, we will integrate this quantity with respect to x. Integration of x cube is x to the power 4 by 4. So, here we will get 1 by 2. Integration of x cube is x to the power 4 1 by 4 and the limits are 0 to 1. Likewise, 1 by 2 as it is, integration of x to the power 5 is x to the power 6 upon 6, limits are 0 to 1. Now, we will apply the limits when we write upper limits, that is x equal to 1 here, this 1 by 8 and here we will get 1 minus When we apply upper limit, we will get 1 to the power 6, that is 6, and 1 by 2 into 1 by 6 is 1 by 12. We will take LCM, so we will get 24, and this would be 3 minus 2, so it would be 1 by 24. That is our answer. Next, we will solve this integral for the limit 0 to 2, 0 to x, 0 to y of this function x, y, z with respect to x, y and z. Here the limits are variables. First, we will perform this integral with respect to z. So, to this integral we can write integral 0 to 2, integral 0 to x, then integral 0 to y. We will integrate x, y, z first with respect to z, then dx, dy. When we integrate this function with respect to z, this x, y will deal like a constant. So, this integral will be 0 to 2, 0 to x, x, y are constants. We will integrate z, it will give z square by 2, and the limits are 0 to y, dx, dy. Now, when we substitute limits, here we will get y square by 2, we will multiply with this y, so we will get y cube. So, 0 to 2, 0 to x, this 1 by 2 outside the integral, and here we will get x, y cube integration with respect to x and y. Now, to this function we will integrate for this limit 0 to x with respect to y. So, to this integral we can write 1 by 2, 0 to 2, integration 0 to x for this function x, y cube, first with respect to y, then with respect to x. Now, when we integrate 1 by 2 as it is, integral 0 to 2, when we integrate this x deal like a constant, and integration of y cube is y to the power 4 by 4. So, here we will get x, y to the power 4 by 4, and the limits are 0 to x. Now, we will apply limits 1 by 2 as it is, now 1 by 4, integration 0 to 2. When we substitute upper limit, here we will get x to the power 4, when it multiplied with x we will get x to the power 5, and integration is with respect to x. So, this will give us 1 by 8. When we integrate x to the power 5, we will get x to the power 6 upon 6, the limits are 0 to 2. When we solve, we will get 1 by 8 multiplied with 1 by 6. When we substitute upper limit, we will get 2 to the power 6, and when we substitute lower limit, the term is 0. So, this would be 1 by 8 into 1 by 6, 2 to the power 6 is 64. Now, just solve it. 8 8 just 64, 2 4 are 8. So, this would be 4 by 3. That is our answer. Next, we will solve this integral for the limit 0 to 1, y square to 1, 0 to 1 minus z to this function z with respect to y, z, x. The limits are variable. First, we will integrate for this limit 0 to 1 minus z with respect to x as per given order of integration. So, this integral is integral 0 to 1 integration y square to 1. First we will integrate for 0 to 1 minus z to this function z with respect to x, then dy, then dz. Now when we integrate z with respect to x, so z deals like a constant, so we will get only x. So 0 to 1, y square to 1, here z we get x, limits are 0 to 1 minus z, integration with respect to y with respect to z. Now when we apply the limits, this would be 0 to 1, y square to 1, z 1 minus z, upper limit. When we apply lower limit, this term would be 0, dy, dz. Now we will integrate for this limit y square to 1 with respect to z to this function. So we will write 0 to 1, integration for the limits y square to 1. We can multiply this bracket with z, we will get z minus z square. First integration with respect to z and then with respect to y. Now when we integrate here, we get this integral 0 to 1. Integration of z with respect to z is z square by 2 minus integration of z square is z cube by 3. Limits are from y square to 1 and next integration is with respect to y. Now we will apply the limits, this integral as it is. When we apply upper limit, so here we will get 1 square by 2, that is 1 by 2, minus 1 cube by 3, so minus 1 by 3, this value is for upper limit, minus, now we will apply lower limit. So when we substitute y square in place of z, so we will get y to the power 4 by 2. Here we will write y square of square, that is y to the power 4, minus, when we substitute y square in place of z, so we will get the term like this, y square of cube. We will use theory of indices, this term is y to the power 6. So here we will get y to the power 6 upon 3 and the integration with respect to y. Now we will simplify this term. So this integral 0 to 1 as it is. First we will simplify this, we will take LCM, that is 1 by 6 and then 3 minus 2. So it would be 1 by 6 minus y to the power 4 by 2 and this minus will give plus sign y to the power 6 by 3 integration with respect to y. Now we will integrate this term with respect to y. So we will get integration of 1 by 6 is y by 6 minus this 1 by 2, integration of y to the power 4 is y to the power 5 upon 5 plus integration of y to the power 6 is y to the power 7 upon 7 and the limits of integrations are from 0 to 1. Now we will write the limits. First we will apply upper limit, so we will substitute y equal to 1, so we will get 1 by 6 minus, when we substitute y equal to 1, this term would be 1 and 1 by 2 into 5 will give us 10 plus, when we substitute y equal to 1 here, we will get 1 by 3 into 1 by 7, that is 1 by 21. Now we simplify this term by taking LCM, and this value is 4 by 35. That's our answer. Next we will solve this integral for the limit 0 to 2, 0 to x, 0 to x plus y of this exponential function e to the power x multiplied with y plus 2z. Now the limits are variable, and as per order, first we will integrate for this limit 0 to x plus y with respect to z. We can write this integral as 0 to 2, 0 to x, integrations from 0 to x plus y, this exponential x, y plus 2z, dx, dy, dz. First, we will integrate with respect to z. So, here we will write dz and then dx, dy. When we integrate with respect to z, this exponential function will deal like a constant. This y is also a constant, and integration of this z is z square by 2. So, this would be 0 to 2, 0 to x, e to the power x, y is constant. So, integration is z plus 2 z square by 2, that is z square. Limits are 0 to x plus y, dx, dy. Now, when we apply the limits, integration 0 to 2, 0 to x, this e to the power x as it is. Here we will get y multiplied with x plus y plus x plus y square dx, dy. Now, we will simplify this term. When we multiply y with x plus y, we will get xy plus y square. When we open this whole square, we will get x square plus y square plus 2xy. So, on solving, we will add these two y square. So, first x square as it is plus 2y square plus 2xy plus xy will give us 3xy. So, on solving this value, we get x square plus 2y square plus 3xy. So, now we can write integral 0 to 2, integral 0 to x e to the power x multiplied with x square plus 2y square plus 3xy. Now, first we will integrate this with respect to y for the limit 0 to x and then with respect to x. Now, on doing integration, we get integration 0 to 2. When we integrate with respect to y, this e to the power x will as it is. Here we will get x square y. This term would be this 2 as it is. Integration of y square is y cube by 3 plus this 3 as it is, x as it is, and integration of y is y square by 2. Limits are from 0 to x, and the next integration is with respect to x. Now, we will apply the limits. Here we will get 0 to 2 e to the power x as it is. We will write y equal to x. So, here we will get x square multiplied with x, that is x cube, plus 2 by 3. We will substitute y equal to x. So, here we will get x cube plus 3 by 2, this x as it is, we will write y equal to x. So, x into x square, that is x cube. When we substitute lower limit, all these terms would be 0 as y equal to 0. Now, when we simplify, we may take x cube as common. So, we will get 1 plus 2 by 3 plus 3 by 2 with respect to x. We will take LCM and this term is 19 by 6. So, now we get 19 by 6 outside the integral, and integral from 0 to 2 x cube e to the power x with respect to x. Now, to further solve this integral, first we will find indefinite integral of x cube multiplied with e to the power x. As we have to apply integration by parts to get this integral. When we solve this indefinite integral x cube e to the power x dx, we have to apply integration by parts, and this would be first function and this would be second function. So, we will apply the rule for integration of part, first function, that is x cube, integration of second function e to the power x minus differentiation of first, so that will give you 3x square, integration of second and whole integration. Now, this is x cube e to the power x minus 3 integration of x square e to the power x dx. Now, in this portion again we have to apply integration by parts. So, this would be x cube e to the power x minus 3. When we apply first function, that is x square, integration of second, that is e to the power x, minus differentiation of first, that is 2x, integration of second. Now, we will get x cube e to the power x minus 3 x square e to the power x minus minus plus 6 integration of x e to the power x with respect to x. So, now this would give us x cube e to the power x minus 3 x square e to the power x plus 6. Now, again to solve this integral x e to the power x, we must apply integration by parts. So, here we will get first function, integration of second minus differentiation of first, integration of second. So, this term will give us x cube e to the power x minus 3x square e to the power x plus 6x e to the power x minus 6 e to the power x. We may take this exponential function as common, and then we will find the value of this indefinite integral 0 to 2 x cube e to the power x with respect to x. So, this value would be 19 by 6. The indefinite integral of x cube e to the power x will give us e to the power x cube minus 3x square plus 6x minus 6. The limits are 0 to 2. Now, we will substitute these limits. So, we will get 19 by 6 e to 2 cube minus 3 into 2 square plus 6 into 2 minus 6. When we substitute this upper limit to minus, we will substitute lower limits, that is e to the power 0. Here we will get 0, here we will get 0, this term would be 0, but this last term is minus of 6. Now, on further solving, we will get 19 by 6, this is e square. On simplifying this term, this will give 8 minus 12 plus 12 minus 6. So, just see, we have this term 2 cube, or that is 8 minus 3 into 4, that is 12, plus 6 into 2, that is 12, and this minus 6. So, this would be cancel out, and 8 minus 6 is 2. So, here we will get twice of e square. Now, minus e to the power 0 is 1, this whole term is 0, and here we get minus 6. So, this minus minus plus 6. This is our answer. So, that is about triple integrals with variable limits. For better understanding of this topic, you may solve some more examples. Thank you so much.